All right, so yesterday we talked about using the quadratic formula when we had to transpose. In other words, when we had to move some terms around, but still, like day one, they were all factorable. So today we're eventually going to look at what happens if they're not factorable. And this is really like the true benefit of the quadratic formula. So let's recap what we did yesterday, right? We need to put this in standard form before we can decide what a, b, and c are. So that's going to leave me 3x squared minus x minus 14. So from that I can determine that a is 3, that b is negative 1, and that c is negative 14. So now I'm going to go to my quadratic formula, right? So I've got x is equal to negative 1 plus or minus the square root of negative 1 squared minus 4 times 3 times negative 14. And that's all going to be divided by 2 times a, which is 3. So negative 1 is positive 1, plus or minus the square root of negative 1 squared is 1. And again, I got to be careful. Negative 4 times 3 is negative 12. Negative 12 times negative 14 is positive 168. And the denominator here is 2 times 3, which is 6. I've got x is equal to 1 plus or minus the square root of 169 divided by 6, which is going to give me 1 plus or minus 13 divided by 6. So now I can split it up over here. So one of my roots is 1 plus 13 divide 6. The other one is going to be 1 minus 13 divide 6. So 1 plus 13 is 14. 14 divided by 6 is 14/6, which we can call 7/3. And 1 minus 13 is negative 12, divide 6 is negative 2. So those should be my two roots. All right, so let's take a look at one where we're not able to factor. All right, so we're taking our regents, let's say, next year, and we see this quadratic equation, and we realize pretty quickly that you can't factor it, right? There's no factors of negative 10 that add up to negative 2. So we say, okay, graphing's not going to help, right? If these are radicals, I can graph it. I can see that there's going to be x-intercepts. My calculator's just going to give me a decimal to 3 or 4 places, but we know that's not correct because they're irrational. So essentially, we literally have two choices, right? One is we could complete the square, which in this case is not going to be horrible because the coefficient of x squared is 1, and because the coefficient of x, negative 2, is even. But honestly, I don't love completing the squared. I would use quadratic formula, and I'm sure a lot of you guys would too. So we're going to say, all right, well, and we would expect that our answers are going to be either irrational, as in a radical, or what we'll call imaginary, as in a negative number inside a radical. And we'll talk about that too. So a is equal to 1, b is equal to negative 2, c is equal to negative 10. So when I use my quadratic formula, I get x is equal to negative 2, plus or minus, right, the square root of b, which is negative 2 squared, minus 4 times a, which is 1, times c, which is negative 10. And that's all going to be divided by 2 times a, which is 1. So that's going to give me x is equal to negative 2, which is positive 2, plus or minus the square root of negative 2 squared, which is 4. And again, I'm always careful here. Negative 4 times 1 is negative 4, times negative 10 is positive 40. And that's all going to be divided by 2. So I get x is equal to 2 plus or minus radical 44 divided by 2. All right. Now I'm okay with you leaving it like this. Okay, I know we simplified radicals months and months and months ago. It's really something you should remember. I know some of you guys did it in AIS. Some of you guys did it with me. Some of you guys did it both. But for the homework, I am fine with you leaving it like this. Do not put it as a decimal. Tomorrow's lesson is where we're going to leave them. We're going to convert them into decimals. So today I want you to either leave it like this or simplest radical form. So I'm going to go over simplest radical form. But again, if this is too much for you, then just leave it like that. The way we simplify a radical is we said we break it down into factors, one of which is a perfect square. So radical 44 would simplify to radical 4 radical 11, which would be 2 radical 11. So now I could rewrite this as x is equal to 2 plus or minus 2 radical 11 divided by 2. And now we say 2 and 2 radical 11 are both divisible by 2. So 2 divided by 2 is 1. 2 radical 11 divided by 2 is radical 11. So this is my answer in simplest radical form, 1 plus or minus radical 11. But again, if that's too much for you, I'm fine with you just leaving it like that. All right, so let's take a look at another one. And this one really should be just as easy, except for the fact that we need to move the term to determine what c is. So in standard form, we're looking at x squared minus 5x minus 7 equals 0. So I know that a is equal to 1. I know that b is equal to negative 5. And I know that c is equal to negative 7. So now I'm going to jump to my quadratic formula, right? So I've got x is equal to negative 5 plus or minus the square root of b, which is negative 5 squared, minus 4 times a, which is 1, times c, which is negative 7. And that's all going to be divided by 2 times a, which is 1. So I've got my negative 5 is positive 5. I've got negative 5 squared is 25. And then again, negative 4 times 1 is negative 4 times negative 7 is positive 28. And the new denominator is 2 times 1. So I've got x is equal to 5 plus or minus radical 53, all divided by 2. Radical 53 is a prime number. It's got no factors, certainly no perfect square factors. So I'm done, right? You don't have to split it up. We will tomorrow when we're talking about decimal values, but that's it. And just to go back to the original one, I would not want to do this using completing the square. If I wanted to complete the square, I'd have to add 7 on both sides, divide negative 5 by 2, right, negative 5 halves, square it, which is 25 fourths, add that to both sides, and then factor it down from there. Not going to be easy, right? Not impossible, but certainly not as easy as just subbing in its quadratic formula. And even after all that using completing the square, you're still going to end up with this radical. So again, just one of the many benefits of our quadratic formula. All right, so let's take a look at this one, right? So on the surface, it doesn't really look that different, but if you really kind of analyze it and think about it, we realize that something's kind of off here, right? So I've got x squared, which is going to be positive, unless x is 0, which is not going to be 0. I've got a positive number term here, a positive coefficient, and a positive number here. So 10 is positive, right? X squared is positive. So even if x is like a negative number, right? If x is like, negative 5, x squared is 25 minus 15 plus 10. It's probably not ever going to give us 0. So now the wheels maybe start turning in our head that something's kind of off here. Obviously, we can't factor it, right? There's no factors of 10 that add up to 3, but there's something else that's going to give us a problem, and it's going to work itself out in the end. So when we establish the values of a, b, and c, right? A is 1, b is 3, c is 10, right? Nothing unusual there. So we say, okay, let's go to our quadratic formula. So we get x equals negative b plus or minus the square root of b, which is 3 squared, minus 4 times a times c. That's all going to be divided by 2 times a, which is 1. So now we've got x is equal to negative 3 plus or minus the square root of 9 minus 40, right? Because negative 4 times 1 is negative 4 times 10 is negative 40. And that's all divided by 2. So I've got x is equal to negative 3 plus or minus the square root of negative 31. All right, so we have a problem, okay, right? If we put this in our calculators, what's going to happen? Well, it's going to give you either, depending on what the model of the calculator is, the older ones I think are going to give you some sort of error. The newer ones are going to say non-real solution, right? And we talked about this, I believe, a little bit with completing the square, right? The square root of a negative number, we can't do, right? Let's take a look at the square root of negative 4. Right, 2 squared is 4, and negative 2 squared is 4, right? They're both positive, but when you multiply a number times itself, whether the number is positive or negative, the product is positive. So this we can't do. So mathematicians did determine, they said, well, let's call the square root of negative 1i for imaginary, right? These negative 31 is what's called an imaginary number. Any negative number in a radical is an imaginary number. Now, you guys don't need to know that really until next year. But all we need to know for this year is that anytime you've got a negative inside a radical, that's what's called an imaginary solution. And you don't even need to know that vocabulary. All you need to know is that we're going to say no real solution. All right, this is what's called, and I'm pretty sure we did talk about this last week a little bit when we did completing the square, but that's all you need to put for your answer. I mean, you're going to write this as your answer, but the actual solution for, as far as we're at right now, we would just say no real solution. So anytime you end up with the quadratic formula or completing the square, if you get a negative inside the radical, that's what's called an imaginary number. We simply say there's no real solution. All right, so let's take a look then at these two. So for this first one, I've got A is 1. I've got B is 3. I've got C is negative 9. So I've got X is equal to negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 9. That's all going to be divided by 2 times A, which is 1. So that's going to give me negative 3 plus or minus my square root of 3 squared, which is 9. Negative 4 times 1 is negative 4 times negative 9 is positive 36. And that's all going to be divided by 2 times 1, which is 2. So I've got X is equal to negative 3 plus or minus square root 45 divided by 2. And again, guys, I'm fine with you leaving it like that. Really what we should do, and again, this will help prepare us for high school, right? If we've forgotten, simplifying radicals, it'd be a good idea to review now because, you will be required to do it next year. We're going to call this radical 9, radical 5, because the only perfect square factor of 45 is 9. So we can call this 3 radical 5. So the best way to express our answer is negative 3 plus or minus 3 radical 5 divided by 2. Now, since the negative 3 and the 3, that's the coefficient of the radical 5, right, do not have 2 as factors, we can't simplify. If this was, let's say, negative 6 plus or minus 8 radical 5, then we can divide those two things by 2. But since we can't divide the coefficient of what's in the radical doesn't matter, just so we know, because someone always asks that, which it's a good question. It's just the constant that's outside, which is negative 3, and the coefficient. So that's the best way to put it, but again, if you left it like this for your homework, that's perfectly fine. And let's take a look at the second one. So we need to do some term moving here. All right, so that's going to give me 5x squared plus 2x minus 4. So now we can determine that A is 5, that B is positive 2, and that C is negative 4. And now we go right to our quadratic formula, and we get x is equal to negative 2 plus or minus the square root of 2 squared minus 4 times 5 times C, which is negative 4. And that's all going to be divided by 2 times A, which is 5. So that's going to give us negative 2 plus or minus the square root of 4. And then negative 4 times 5 is negative 20 times negative 4 is positive 80. And that's all going to be divided by 10. So I'm looking at negative 2 plus minus radical 84 divided by 10. And again, I'm fine with you leaving it like this. If we want to simplify it, which we should, right? Radical 84 is really radical 4 radical 21, which I'm going to call 2 radical 21. So now I'm looking at negative 2 plus minus 2 radical 21 divided by 10. Now what can I do to simplify this? Well, technically I can say that all of these terms are divisible by 2. So if I really want my simplest possible answer, I would divide everything by 2. So negative 2 divided by 2 is negative 1. 2 radical 21 divided by 2 is radical 21. And 10 divided by 2 is 5. So again, right, I'm fine with you leaving it like this. It would be a good idea, though, to simplify the radical. Again, it's going to be good practice for high school. And ideally, the best possible answer is going to look like this, right? Negative 1 plus minus radical 21, all divided by 5. So make sure, again, guys, tonight you're using quadratic formula. The only alternative would be completing the square anyway, and something like this is going to be really, really difficult for you to do completing the square. And as always, guys, any questions, you can get me on the chat, or you can get me through, through a private message. And then tomorrow we're going to kind of wrap this up with converting these radicals into decimals.